The union of two equivalence relations on a set is not necessarily an equivalence relation on the set. Okay, let us begin. So first what we'll do, we're going to consider two relations that are equivalence relation. So let's say those two relations are denoted by R and S. So let R and S be two equivalence relations defined on the set A. Now, what we'll do, our task will be to check for R union S. So here, if we take R union S, we need to check whether if this relation is an equivalence relation or not. So that means we need to check for its reflexivity, we need to check for its symmetry, and we need to check for its transitivity. So we'll begin by first trying to check for its reflexivity. So here, to find out the reflexivity, so let's say let us consider a arbitrary element A. So let A be an arbitrary element of the set A. Then, if we say that the element A has been picked up from the set A, this must imply that the ordered pair A comma A belongs to the relation R, or the ordered pair A comma A belongs to the relation S. Now this is true because we know that R and S, these are both reflexive relation because they are equivalence. If they are an equivalence relation, immediately we can say that both of them are reflexive relation. So the ordered pair A comma A belongs to R or it belongs to S. Now we can also rewrite this as the ordered pair belongs to either R or S or both. So that means we have the ordered pair A comma A belonging to R union S. Thus, if an ordered pair A, the ordered pair A comma A belongs to the union of the relation R and S for all A belonging to the set A. So this is simply telling us that the relation R union S is reflexive. Fine. So this is a reflexive relation, so that's fine. Now we will check for its symmetry. Now to check for symmetry, let us suppose that we consider two elements A comma B belonging to the set A such that we consider A comma B belongs to R union S. So we're assuming that the ordered pair A comma B belongs to R union S. Then we can say if A union B belongs to R union S, then we can say that the ordered pair A comma B belongs to either R, or we can say the ordered pair A comma B belongs to S. Fine. Now A comma B belongs to R. Can we not say that B comma A also belongs to the relation R? That's because R is symmetric. Similarly, A comma B belonging to S can be also expressed as B comma A belonging to S. That's because R and S, they are equivalence relation. If they're equivalent, the relation, then they are automatically symmetric. So R and S are symmetric relation, and that's the reason why we are able to say that if A comma B belongs to one relation, then B comma A also belongs to the same relation, which means we can now combine these two statements and state it as B comma A belongs to either R or S. In other words, we are saying that B comma A belongs to R union S. Fine. So what we have done here, thus we have shown here that the ordered pair A comma B belongs to R union S implies that the ordered pair B comma A also belongs to the union of R and S, the relation R and S, and it is true for all A and B belonging to the set A. Fine. So this implies that relation R union S is it's symmetric. This is a symmetric relation on the set A. Okay, and finally we're going to check for transitivity. Now in order to check for transitivity, we're going to consider three elements, and let those three elements be A, B and C. So let's say let A, B and C belong to the set A such that the ordered pair A comma B belongs to R union S, and we have another ordered pair B comma C also belonging to R union S. Fine. Then what can you say about this? Then we can say that A comma B belonging to R union S and B comma C belonging to R union S would imply that A comma B, the ordered pair A comma B belongs to R or we can say the ordered pair A comma B belongs to the relation S, and the ordered pair B comma C belonging to R union S simply means that the ordered pair B comma C, it belongs to R, or we can say the ordered pair B comma C belongs to S. Fine. Now, this particular give rises to 4 scenarios. The scenarios being, we can consider A comma B to be belonging to the relation R, and we can consider when we combine the statement, we can consider B comma C to be belonging to the relation R. So this is one possibility. Or we can consider A comma B, the ordered pair A comma B, to be belonging to the relation R, and B comma C to be belonging to the relation S. So this is the second possibility. The third possibility would be, we have A comma B belonging to the relation S, and we have B comma C belonging to the relation R. Or we could have the fourth possibility where the ordered pair A comma B belongs to the relation S, and we have the ordered pair B comma C belonging to the relation S. Now, this statement and this statement is perfectly fine. So if A comma B belongs to R and B comma C belongs to R, we can immediately say that A comma C is going to belong to the relation R, because R is a transitive relation. Similarly, this fourth statement, this is also going to give us the same statement. So this is going to tell us, so here let's specify that this is the statement that A comma C belongs to R, or we can say this particular statement telling us that A comma C belongs to the relation S, because S is a transitive relation. However, the problem arises because of these two relay statements. So here A comma B belongs to R and B comma C belongs to S means that A comma B only belongs to R and B comma C only belongs to S. To work for transitivity, the ordered pair A comma B and B comma C must belong to the same relation, but here both belonging to two different relations. Similarly is the case for this statement, A comma B belongs to relation S, whereas B comma C belongs to the relation R. So here we cannot conclude for sure that even though R and S are transitive, we cannot conclude that A comma C is definitely going to belong to R intersection C. So this is not necessarily true. So if we consider only those two statements, then yeah, it makes perfect sense that we can say that A comma C is going to belong to R union S, and that would have sufficed to say that our given relation R union S is also transitive. However, because of these two statements, we cannot say with surety that our relation is a transitive relation. So here what we'll say, so R is not transitive. So R is not a transitive relation. Now if R is not a transitive relation, so here we can safely say that thus the R union S is not an equivalence. This is not an equivalence relation on the set A, right?